Okay, I'll just invite him to Swiss mathematician, Jacob Bernoulli. Thanks to him, we are doing his math work right now. Bernoulli random variable is a discrete random variable. Now, I hope you remember that we've done in E11 the discrete probability distribution. We are revisiting that as well.
How well do we have to remember that?
You need to go back to your note, discrete probability distribution, and revise. And some of the stuff we're doing today is continuing from that. So you will sort of remember it, hopefully, when you revisit. Biggest thing here about Bernoulli is we are playing with only two outcomes here, success and failure. Success is 1, failure is 0. Okay, so example 1, first one, turning up a tail when tossing a coin. Is it Bernoulli random variable? Yes, because it's a tail or no tail. So there's a 2 outcomes. The number rolled on a die, if it chose a number for us, say that rolling a number 5, then it's a different story because it's either 5 or no 5. Die has 6 outcomes, so didn't really indicate anything about what specific outcome we're looking for, so it's not. Okay, part C, hitting a bullseye when throwing a dart. It actually tells what we are aiming for. Okay, that's success if we get that. If we don't, also fail. So yes, it is. And the next one, the number of goals scored by a hockey team in a match. Number of goals, it's just too many things involved here. Okay, so therefore it's not. Okay, so the next one, choosing a red ball. Okay, so now we're talking Bernoulli here. So it's either red or no red, or we only got 2 outcomes.
I'm kind of confused what the 0 and the 1 mean.
0 is not succeeding. You're not getting the outcome that you want.
Oh, okay. So it's not the probability. It's just the outcome.
It's going to turn into probability.
It's going to turn into probability, but the 0 doesn't represent the probability.
That's right. So at this point, we are looking for whether we're getting the outcome or not. So hopefully you'll get some feel for this Bernoulli distribution. Example 2, construct a discrete probability distribution table and bar graph, which I'm going to say it's actually histogram, rolling 6 on a die. Now, this is Bernoulli distribution because it's 6, no 6. So you're getting 2 outcomes here, 6 and no 6. Success, so it would be 1/6, and this is no success, so that would be 5/6. But we are now doing the probability, and if we construct the histogram, this is what we're going to get. With the table, top value is x values, the bottom one is the y value, which is the probability, the fraction part. Just careful with the scale of the y values. It's going to be a fraction because it's probability. Next one, is this a uniform probability distribution? A uniform means just equal chance. Is it getting equal chance? No, it's not, because they are not the same. There is a more chance to getting 0 fail than success. So it's not even, it's not equal chance. So therefore it's not uniform probability distribution. The probability of failure will be Q equals 1 minus P. If we say success is P, failure, we're going to call it Q. 1 take away P because it's a whole probability is 1. So Bernoulli distribution form, you need to write 2 outcomes in a P form. This, we can say Q. Next one, we call P a parameter. In statistics, the parameter is a constant that describes a feature of a distribution. Example 3, write a Bernoulli probability distribution. This is the format that you have to remember. Whenever they say to write Bernoulli distribution, this is what you have to do. Passing a test where probability of a pass is 56%. Pass is the success, and we can write it as a P of 1. Therefore, your fail, P of 0, is 44%. And then if we write it in terms of Bernoulli probability distribution, that's what you're going to get. So that's the success when x equals 1. And that 44% is the fail when x equals 0. Flipping heads. So that's our success, and tail is our fail. Bernoulli probability distribution. I will have to write a P, big X equals little x equals 2 outcomes. It'll be half, both half chance, for x equals 1, for x equals 0. That's it. That's all you have to write. Next one. Selecting a red is our success and blue is not success. So what is a total? Sample space is 15. 7 out of 15 is a success. 8 out of 15 is a failure. Probability distribution, this is the one. Now, next one. Which of the distributions in part A are uniform, equal chance? Obviously, tossing a coin, half chance. Okay, so that's what it is. It's my dog. Now we are entering the real deal here. I hope you remember this. Capital E of X as expected value. Mean, mu, or expected value, they're the same.
Wait, will we need to know the formula for expected value?
This is the year 11 knowledge. R of X is our mean, and the mean is a mu. Mu is now expected value E of X. Now, when we are trying to find the mean, the average, we did the sum of the f of X divided by sum of the frequency. The sum of frequency, we can actually convert that to n. So now the mean E of X equals the sum of f of X divided by n now. Okay, that's actually can convert it into a sum of x times f of n. And the f of n is actually probability because you're choosing a special event out of a whole event. That's a probability. So to convert that to in terms of P of X is that E of X equals the sum of X times P of X. That was assumed knowledge on here, right there. Now, with that, we're going to make expression on this one. So the sum of X has a two outcomes, 0 or 1. The probability has a two expressions. One is P, the success, and the Q is a fail, 1 minus P. And it's a sum of, so we have to add them, add the fail case and the success case. So if we do that, you will get P as the answer. Okay, that's why we got E of X equals P, which is the success. Okay, so E of X, the mean of Bernoulli distribution, is success, P. All right, so let's have a look at the question. Example 4, find the mean. Now, when it says mean, you automatically start thinking E of X, that is success, P. This is one of the expressions in the table. When I look at the X value 0 is fail, which also is Q, and then 1 is success, and that is a P of 1. When you think of as a mean, is the E of X, P of 1, which is a P, which is success. So what is my P? 4 over 11. Okay, this is another expression that we can use for Bernoulli distribution. X equals 1 is our success. X is 0 is our fail, which is Q. E of X is success. Therefore, P equals 9 over 10. Okay, next, variance. I hope you remember variance. When you get to this part, this is the proof for the sigma. And when you come to this part here, I change that to in terms of E of X. This mu here is the mean. The mean is E of X now. So I replace that with E of X.
Wait, Miss, I'm sorry, what?
You see that the mu here?
Yeah.
I changed that to E of X.
Okay, so right, okay.
Yeah, that's all I've done. Okay, because now we're going to use E of X. And it's times by P of X, which is the probability. So with the X, we had 0 and 1 choice, which is the success. So I'll just put as a P. And then P of X, the probability, we got two cases, fail, success. Success is P, fail is 1 minus P. And all need to be translated in terms of P. And then add them together because it's sum of. We are looking at the fail case first. This is the fail case, and that's a success case. Fail is what? 0 minus p squared. So I put 0 on the x, and then e of x turn into p, success, and then we have to square it, and then times by the fail case is 1 minus p. Okay, you times it together, and that's our fail case, and then plus success case, and then we have to add it all together is our variance. So success case is 1 take away p, because we've done the 0, x equals 0. Now we're doing the when x equals 1. So it'd be 1 minus p, and then we square it and times by success p here. That was the hardest part to understand. After that, it's just algebra. So what happens? 0 minus p squared is a p squared, and there 1 minus p stays the same, and plus 1 minus p squared is actually perfect square, isn't it? So we expand it as a perfect square, which is 1 minus 2p plus p squared, and then times by p. Now we expand it again, and then simplify. It'd be p minus p squared, and then we factorized. So now you need to memorize this. Variance of x equals p brackets 1 minus p. I think the hardest part is the actually converting in your head the success expressions and the failure expressions.
Will we have to know this proof?
I can't really say yes and no. I think most likely you probably have to utilize the proof into solutions. So you do need to understand the proof to be able to freely use the proof to help your solution.
Okay. So it's just something you should know.
Yeah, definitely you need to know this to help you further. This is our normal table. X, you've got 2 choices, 0 and 1. P of x, that's the fail, that's a success. Now, if we change into variance, this x becomes the x minus p squared. Then the 0 case will change into this. That's all. So when you look at the pattern here, it's x minus p squared. So each x case is 0 and 1. You just have to do a take away p, square it. That's all. And the p of x case doesn't change. And here I've times the success together. This one, success, and this. I times it. So that's what this is. I times it. Failure one together like that. And that's what I've got here. And I add them together because it's the sum of. Let's have a look at the question. Example 5, find the variance. Okay, so formula was p and brackets 1 minus p. That's what we're looking for. If we can find p, we can find the variance. So how are we going to find the p? E of x is p, isn't it? And p is success, which is here, is this one, which is 0.6. So therefore, variance of x equals p 1 minus p. So all I'm going to do is 0.6 times 1 minus 0.6 equals 0.6 times 0.4. Now, just a little note here, 0.4 is our failure, okay? So success times failure, okay? That's the formula. The answer will be 0.24. This is another expression here. Find the variance of x. Here, all you have to do, p times 1 minus p, which is p times q. P is e of x, which is p of 1, the success, 3 over 5, and the q was 2 over 5. So all I have to do is 3 over 5 times 2 over 5, which is 6 over 25. So that's a quick formula for variance. All right, that's all for today's lesson. Well done. Thanks.